let us study the steady state heat conduction through a rod of uniform cross section. So, here we will develop the concept of thermal resistance, and we will also see how the heat conduction is similar to a current conduction, that is the analogy between heat and charge flow, heat flow and charge flow, that is heat current and this electric current. So, here I have a uniform conductor of cross section, uniform cross section area A. This matter is isotropic, means it has same conductivity K in throughout this medium, that I say K, and this length is suppose L. So, this side we have suppose temperature, higher temperature, some temperature, higher temperature suppose I say T2, T hot, and this is T cold, or suppose I say it is T2, T1. So, now using Fourier law, using Fourier's law, that is dq by dt is equal to minus Ka d theta by dx. So, dq by dt is heat current and this is minus Ka. So, here that is I will say, suppose I measure here x direction. So, this is x1, this is x2. So, that will be T cold minus T hot by L, that is I is equal to Ka T hot minus T cold by L. So, T hot minus T cold by L. So, we can write this I as delta T, the temperature difference, by L by Ka, that is further written as delta T by RTH, where RTH is equal to TH is equal to L by Ka is called thermal resistance of the rod. So, you see here the temperature is here higher. If I plot a graph of variation of temperature, so here this temperature is plotted T and here this x. So, here it is T2 and this is higher, this temperature uniformly decreases to T1 value in this length. So, this temperature decreases uniformly to T1 value. So, if I want to know what is the temperature here, you can see this is the temperature here, this is less than this T2, T1. So, now just compare this with a resistor. Suppose this is a resistor, thermal resistor R, and here I have applied plus V voltage and here I have minus V voltage and a current, the electric charge flows. So, I used to write I is equal to delta V by R, this is R current. So, this is electric current and this is here we can write this as this equation. So, you can see the analogy between the electric current and the heat flow, both equations are similar. So, we talk the conductivity of heat also in terms of the resistance, that is the thermal resistance. So, the similar ideas we will develop in heat conduction similar to the current conduction, which is the series and parallel combination of resistors, Wheatstone bridge and all such things.